Welcome to the Long Range Pursuit Podcast, presented by Gunwerks, where we learn about and share long-range shooting techniques, science, and gear. Okay, welcome to Long Range Pursuit Podcast. We have two Gunwerks engineers here. Not just any engineers, these are Gunwerks engineers. Josh Moore and Avery Smea, right?
Correct. Yeah.
Got it right?
Yeah, it's a tough one.
Yeah. We're not going to spell it for the cameras, but it's a tough one. Yeah. So I developed that pronunciation right off the bat. I think I've got it approved already, so we're good to go.
We'll take it.
New team, and one of the challenges with a new team, engineering-wise, is just learning how to interpret in the communication side. And one of the big things that we do there is we, create, requirements documents and, try to write everything up and share pictures and put details in. And it's a little bit of a challenge to pass that communication. So the best way to get to know each other is to do a cool project. And we're going to talk about one of the biggest engineering projects that Gunwerks has ever done, and it's called the Nexus rifle system. And pretty excited to share this with, customers and non-customers alike and listeners of the podcast. And there's some really cool features that we'll talk about today. But probably the most important thing is to share some backstory on the why and what we did. All the marketing stuff and all the really cool details, hopefully they can get access to on the website, and dive into it and kind of see it and experience it. So it's up to us maybe in this podcast to share a lot of the backstory, some of the challenges we overcame and some of the most important things that we saw. So I want to kind of break down, what the Nexus rifle entails, and then we can just maybe pass that back and forth and just kind of bounce off some ideas. So if you think about a rifle system, there's two very significant components. You've got the rifle stock, that's the touch points. That's like everything that you touch and handle. Then you've got the receiver. And, let's just assume barrels are barrels, other than changing the contour around, a barrel's kind of a barrel. So what I want to point out for our listeners is Avery was our lead engineer on the receiver portion. And so that is the NXT is the model receiver. And Josh was the lead engineer on the rifle stock. Now that's probably because Josh has a very significant design experience in composites. And if you have to make it, or you're in charge of making it, then your design will be suitable for the manufacturing of that. And Avery has demonstrated a very nice skill in some mechanical concepts, and so it balanced out the workload pretty well to assign it that way. So Avery, why don't you share with us just a little bit about kind of the spool up for you getting into this receiver. What's your understanding of the original design intent with that product and some of those features that we saw there?
Yeah, so I guess any big hurdle when it comes to a design project is kind of getting your concept across to one another. And you mentioned requirement documents and stuff like that, but it seems like we all have a different view of where we want to go, and so we had to set some hard limits on what we needed: aluminum action, full diameter bolt.
Hard limits, like fixed requirements. Those don't happen around here.
Yeah,
do
I was
they?
going to say those don't exist here.
They were material choices, right? To the extent of let's not choose some heavy carbon steel or something like that. The goal was an aluminum action. And a lot of that was driven by supply chain. So
you back up one step. Really, the goal was vertical integration.
Yeah.
With a receiver that approaches the weight of our existing titanium. That was the goal.
Yeah. And
aluminum was the solution that was for various reasons, including supply chain.
Correct. Yeah. And we had wanted to bring things in-house. We have a new facility here that we are filling up with machines quickly. And one thing that we felt we could save cost on was bringing actions in-house, and we could do a phenomenal job because we can check all the quality.
Save costs, perfect. Love it. I mean, that's a great motivator. You need to pay for the machines that they're so dang expensive.
Yeah.
But the real reason that we want to vertically integrate is, number one, quality control. We have 100% control over quality. And number two, we can get it when we push the button.
Exactly.
So for us, disrupted supply chain has limited our ability to grow and scale and to serve our customers better. So really, like from my perspective, it's like I want to make them so that we can actually have them made and done and produced for the customer and shipped and done. I mean, if you can save cost, you're also doing your customer a service, right? And that's, as engineers, we're all engineers here. It's like the goal is to produce value for the customer. So saving some cost is a good side benefit.
Yeah, and a nice thing is we get that control over the quality. If we need to tweak something, like you said, push of a button, we're right there. We can modify it to work for us, so that it is exactly what we want, hold the tolerances that we want. And another thing that we did with this rifle is the full diameter bolt, and we've had a lot of issues with lugways in the past. Binding up, tolerances would be too tight, and then by the time you put a coating on there, we have some
manufacturing, everything. Yep.
And so there was a lot of things in this action that we had free reign on to improve over Remington 700 clone. We were able to do new ejectors without a spring pin, for instance. It's a minor thing, it still functions the same, but we were able to make it easier for teardown or put back together assembly by our manufacturing team. And so there's a lot of cool things that we could do with this project, and that's kind of what it gave us the ability to do, is clean slate, improve where we need to.
We ended up in a different space on the rifle stock. Like the original goal was developing a new process and kind of wrapping a new stock design around it. We didn't end up there.
Yeah, I mean, you kind of touched on it. When it comes to stocks, it's not only design but process, and really where Avery was making a lot of headway on the action, and that's really what drove that, right? Is we're in a really good place on that, and let's get a stock done for it, and that's really kind of where it started, right?
Yeah, one of the cool things that we did with this receiver, the NXT receiver, is thinking into the future. We wanted to break away from the Remington 700 platform, but I asked if we can keep the bolt spacing the same, then it gives us so much flexibility in the future for how we incorporate that receiver into existing stock designs, right? Yep. Or aftermarket sales.
Yeah.
And so that was a specification that wasn't a fixed or hard or required, but we were able to hit it. And now it kind of gives us a little flexibility. But because of the uniqueness of this product, we felt that it deserved a new stock style, a new design.
Yeah, definitely.
Yeah, so you kind of came into it mid-project, with this goal of improving on, existing, Gunwerks rifle stock designs.
Yeah, definitely. And the main focus there was the touch points, and that's kind of where the leather came into the fold. And when you look at a stock, there's definitely performance-based metrics on recoil management and things of that nature. But I mean, I think the big focus on this was just the touch points, the cheek piece and the grip, and those are the main areas of focus on this.
Well, when we developed the Climber, Magnus, and Verdict stocks, we did a huge design study. You guys weren't here when we did that. That was many years ago when we first started manufacturing stocks. And in that design study, we found the specific design geometries that you manipulate to change the behavior of the rifle.
Yeah.
So there's some very specific things like comb, toe, grip angles. And what we did was developed those three stocks on a spreadsheet.
Yep.
Through that design geometry and the the dimensions, angles, and specifications. Essentially, we designed those stocks on a spreadsheet. We plugged those into a silhouette. Back then, we were using SolidWorks.
Yeah.
And so it was a configuration, and you could literally see the progression from the climber to the Magnus, and adding more grip, flattening the toe line. And what you also see is that the comb stays the same across the board. And so you start manipulating those shapes and sizes to get like the compact mountain rifle in the climber, or the the tactical ELR rig in the Verdict, and everything in between. Yeah. So you got the benefit of that existing knowledge and experience.
Yeah,
and so it kind of shaped some of your design. But I would say the grip area is probably where our focus came.
Yeah, that was the main portion of it. And as far as the grip goes, we really ended up with a couple of different thumb shelf options where you can have. We basically took the Magnus thumb shelf and widened it so that you could have a little bit more of a solid thumb acquisition on there, and then also added a thumb shelf on the top as well, and really tried to design that for the hinge point on your thumb so that it could just lay right on the top.
Yeah, there seems to be, like, in this space, a long-range hunting stock. Like, when somebody pictures a long-range hunting stock, they picture a Macmillan A5. Like, that's the old school classic methodology. Yep. And so a lot of guys are real familiar with laying the thumb right up on top.
Yeah.
And so what we provided with this Nexus stock design was that traditional interface.
Yep. Yeah, it is.
But then also the latest iteration of our thumb shelf, which is a thumb on the side of the stock of your hand. So right hand side, right hand thumb.
Yep.
And that changes the way you control the rifle and interface with it.
Yeah, I think a big part of that is also kind of the bridge that goes between it. It helps eliminate you wrapping your thumb around the grip and choking the gun.
Yep.
Putting that unnecessary torque into it.
So you guys are like the whole engineering team, barring Jackson. It's like what, 6'4" and up, right? You guys are all these big, tall guys, and I'm the small hand guy. So I have to make sure that the stock fits me, and then you guys can just deal with what's left, right?
Yeah.
No, the important thing is accommodating all these grip sizes. Yeah. And if you go to the Magnus and Climber, and you look at what that thumb shelf does, it's very, very interesting, because you put your thumb on that shelf, and then as you slide it down, it moves your hand back away. And so we talked about the angle of the grip. Well, if that was completely vertical, and a lot of stocks are, right? But if that grip was completely vertical, you wouldn't be able to slide down that shelf, you with a bigger hand, and to move your hand back so your trigger interfaces with your finger correctly.
Yeah.
Right? And so those grips are adjustable based on the size of your hand. On the Nexus, the really key feature was the way we put the trigger guard in place. And now you anchor off your middle finger on the bottom of that trigger guard and put your thumb on that shelf, and the grip is what the grip is.
Yeah.
You can't adjust, you can't shift around. It literally locks you in place, and it feels really good. It really does. Yeah. So what we did, to accommodate that, was we made the trigger shoe adjustable back and forth. So now you can adjust the trigger to fit your finger rather than your hand to the grip. So again, it's just the elevation of everything that we know and how it works, right? Knowing how it works allows you to make a design that is enhanced, or it achieves the next level of performance, right? So I would say that was probably the biggest development.
Yeah, it definitely was.
From a visual point of view, the leather is cool.
Yeah.
It really is.
Yep.
And from a touch, like you think about the two places that you interface with a rifle, cheek piece, grip.
Yep.
Now all of a sudden you have a really nice touch.
Yeah.
So I think that's fairly significant. So it elevates the level of quality, fit, and finish in our system.
Definitely.
And introduces a level of complexity that nobody wants to take on. Like we always do this. We always say we want this, and we do it, and then it just makes our job so much harder, when it would be so much easier just to mail it in and just do it like everybody else.
Yeah, definitely.
It really would.
I kind of wanted to throw something out there, like all of the different things that go into leather and leather selection and all the processes that go into it. Like, I always joke, like I went to Montana State University, and they didn't have any leather classes in engineering school, right? So like there was an exponential learning curve there on just different types of leather, thicknesses, all the different processes that go into folding it correctly, And I definitely learned a lot in the last 8 or 9 months, just related to leather.
Yeah.
You know.
Yeah, it's definitely a defining feature of that rifle system, visually for sure, and then when you touch also. The other thing, and it's kind of funny how design concepts just iterate, right? And so you start in one place, and then it just kind of goes to the next, to the next, to the next, and then pretty quick you end up with something that's not really, where you started.
Yeah.
And I would say our Arca rail is a little bit like that. You know, that came in about mid-project, and I asked for an Arca rail that would be just part of the system. So there's some really cool stuff that comes out of that. I mean, think about how stiff our forend is. That stock don't flex.
No, not at all.
It got rid of the bottom metal. So we kind of changed a few things, the way we do bedding blocks and the
Trigger
interface.
guards.
Yeah. So that one I think was a really interesting generation of, an idea and integration into the system.
Yeah, definitely. That, my biggest concern going into that was just the overall carrying. When you're carrying your rifle, having that be obtrusive, but it really isn't. Like where we ended up on the stock and how it mates up with the rail and everything. I mean, you can tell it's there, but it's not obtrusive at all.
And those feature lines that we added some lines, grooves on the side by the magazine port, and it's kind of centered up where you'd want to hold it anyways. The rifle balance as well at that point, and it adds a little bit of texture. It doesn't feel like it's going to slide forward or rearward at all. It just kind of grips your hand pretty good.
Here's an example of how design morphs. Originally, that Arca rail was going to run all the way back to the trigger guard. And when we did some prototype testing, we basically built assembled some prototypes, put them into Arca vices, and essentially reefed on them and just totally tore them up. And realized that it wasn't going to work because of the size of the member back there. No, that was interesting. Well, that drove us to have a flat magazine bottom, right? And here we are right at the end of the project, and we decided that the flat magazine bottom creates a user tactile interface where they're not able to feel like they fully depress the magazine. So literally, whether we need the space or not, the magazine needs to be slightly proud, for the user to feel like and get the feedback that he seated the magazine in place. Those things are so funny how it was flat because of something that we wanted to do that never even made it, halfway.
Exactly. And when you're just talking about it and you're concepting things out, you don't really realize some of those features, right? We didn't realize until we made it that this is maybe not the way we should go. There's a user interface here that doesn't quite work the way we want it to.
What would you say is the most significant thing we learned about the receiver, rifle system development?
About the whole receiver,
the whole thing. Like if you're going to start again from scratch, what did you learn?
Well, first off, you got to have someone you trust running the machine. I would say that was a big hitch point, and we got through that, and after that, we got to a point where we could reliably make our concepts. Then,
So fairly significant, and we can talk about this separately, is the ability to prototype your parts in-house.
Yeah.
That huge.
Let's circle back to that one and make sure we don't forget to talk about it. Keep going.
Okay, so when designing this thing, we wanted to integrate a lot of the features that we've kind of developed for the Remington 700 clones, the two lugs, stuff like a vertical bolt button release, for instance. And we found out with a full diameter bolt that if you just rotate the bolt handle up, it just pops right out, and it can rotate and swing free as a bird. But one thing that we were able to do is just prototype that. We did it in-house.
Prototyping's huge. What else did you learn? I felt like we went at it backwards. Like I felt like at the end, when we're trying to finalize the magazine, what we realized was you should develop the magazine first and wrap the gun around that.
I think we had more flexibility in the receiver design, right?
Yeah.
Our magazine, that geometry's got to work.
Yeah.
So you're pretty confined to what angles and bolt face contact you have but we already had an action we were somewhat locked into at that point.
Yeah.
And that was a difficult.
Somewhat locked into.
we had them made, okay? They were
Yeah.
made and coded. We had them back in our hands. So by doing that, it really restricted us. And next generation, or just the next iteration going forward, we're gonna fix a lot of those issues because we know that now.
Yeah. Yeah. And fortunately, we're able to, because the manufacturing is vertical, right? Because we're machining, aluminum and steel and all that stuff here,
Yep.
we're able to make some small changes. And before this thing gets released, it gets released with the proper, magazine to make it work. So it's pretty cool.
Yeah.
On the rifle stock, we started with this discussion about, hey, we were going to develop a new process. What happened?
Yeah. Yeah. Well, I mean, as far as
Aaron
processes.
happened.
Yeah. Aaron happened. Yeah. I mean, as far as processes go, there's just so much time, work, and energy that go into it. Right. And really where I think we got, like I was saying, is Avery's action got to a really good place. And it was kind of like, hey, let's get a stock going here. And it really came down to, well, how do we go execute this? And, it kind of pains me to say that we stuck with the same process, but it's working, right?
Yeah.
I mean,
Well, I think when we started getting into the leather, like we built a whole set of two sets of tools,
yeah,
for one method, and then it didn't work.
yeah,
And we had to readjust the molds for, the step overs.
yeah, the
And
offsets.
I think what we found is that our process with our silicone ladders creates such a high pressure situation, pushes composites into the corners. It lets you do some things like we're doing to get these leather grips in
yeah,
that you might not be able to do with other processes.
yeah, definitely.
And so like our process is very suited to like the hard lines, the curves, the shapes, of the Nexus rifle stock.
yeah, and like that was one of my concerns going into it. There's a lot of tight corners and just don't work very well with composites.
That's
And
why you
it's-
see most rifle stock designs have a lot of soft edges.
like really ergonomic.
Yep, rounder bottoms.
Yeah, that's exactly
especially
why.
that flat bottom that we have on the bottom of our stock. You don't see that out there very often because you need to have this radius or these slopes so that when you put those two shells together, you can demold the product.
Yeah, yeah.
It's a pretty big challenge.
Yeah, definitely, and it is our process that really helped us get there. I mean, like I said, that was a big concern of mine, and I mean, we made one stock and it came out awesome. So,
Yeah.
So that was a big relief there for me.
Yeah, I think the stock's great, and the feedback from shooting it is and we really need to dial in on identifying all the ways that it contributes to a better shooting experience.
Yeah.
Because you have your theories going in, you make some adjustments on some size, and remember we made a bunch of these out of wood. We would just machine them out of wood, and then we'd go test them and make sure that we liked it. Before you go to a hard composite tool. So once we're using that and you're in the field and you're at the bench, I feel like the grip being a little bit taller, right? And then having that trigger guard kind of stop your middle
was a big
finger
one, yeah.
so you don't choke up as high. You're actually gripping a little bit farther down on the stock, which gives you a little bit more lever, a little bit bigger moment that you can apply to the stock to counteract the spin up torque of that bullet.
Yeah.
Because a gun wants to lay over, and now you've got your arm, your hand, your grip down a little bit lower, gives you just a little bit bigger lever. So I think with less control, less input on the control, you actually exert more control over the stock. So I think that was a fairly significant change in the experience because the comb's the same. The toe lands real
toe is
close
the
to the Magnus.
Yeah, it's pretty much it's the same
Little
angle.
flatter.
It's the same angle on the bottom. It's got the flat bottom to it as well. If anything, I would say it's a little bit narrower because we have those little the rear bag recesses, call it, in there. But other than that, it's pretty much right on top of Magnus.
I'd say another big part of just that torque up and resisting that is our Arca in the front. So when you're shooting off of a rest, it's a nice flat bottom. And
The
it's
flat on the
wide.
bottom of the Magnus is what,
it's
an
like-
inch?
Yeah, and this is
And now you've
probably
got an
2
Arca,
inches.
which is inch and a half.
Yeah.
And
It lays flat on there. There's a lot of
It does track
free
real nice,
moving.
doesn't it?
Yeah, it's not like it's gripping the bag or the rest, right? It slides nice on that. That anodizes a very smooth lubricated coating.
Well, why don't we talk about the manufacturing, prototyping, vertical integration concepts for a little bit, and then we can move on and just dial in on like the core feature sets that we're really excited about. So on the receiver side, just ballpark, how many different prototype parts, sum total, like all parts added up, how many different prototype parts to get to the finished product that we showed our teams and our customers and our dealers last week?
It's got to be over 200 parts. Pretty easy.
Easy.
I mean, by the time you think of all the first iterations of the bolt head, barrel extension, action,
Bolt
stuff like that,
releases.
bolt
Well,
releases.
I'm just thinking on safety cam.
Yeah.
That
Like
too.
how many of those did you make?
I probably made 15 to 20 different safety cams.
Safety cam. That's
and
just
then,
the safety
and
cam.
then to go along with that, you have shrouds, right? I mean, like the shrouds have to be adjusted for all that stuff too.
Yeah,
So
it didn't seem like we could change anything without affecting another part.
yeah,
Like through the
There's-
whole process.
there is trickle down with anything in that system. You know, you change.
I think
one
your
and
200 parts is grossly understated.
Yeah, I was thinking like
sufficient
500,
stories. What it is.
600.
It's, yeah.
How many receivers did you do?
Yeah, I would bet we did 200 receivers.
We don't have 200 receivers.
I'll
though.
bet you did.
we-
60.
We've got like
I get-
50 on the shelf back in
Yeah,
engineering
I'll bet
right
you
now.
did 60.
There's not that many different iterations though. I got a lot where there's some questionable machine marks into them. So
Yeah.
Yeah, but part of prototyping is, can you make it?
yeah.
Yeah.
So and we had to get some special tools to do it, right? I mean, like
Yeah.
we got form cutters and just some specialty tools that were able to.
Yeah, I think how many he made to get the bore the way that he wanted it inside the receiver.
Yeah,
There's probably 10 or 15 just right there.
Yeah.
yeah.
That's just that one feature on that one
right.
part.
So we're like 700, 800 parts.
Yeah.
Yeah.
If you said 1,000, I probably wouldn't have choked on that number because it was a massive lift. Now, in the old days, right? So the way that we would do this is that Gunwerks does the engineering, right? So we create a part, a design, create prints, quality, tolerances, etc. And then for most of the parts, those would go out to an outside vendor, right? And that vendor would quote making that part to our design and specifications. They would make the part, ship it to us. We would QC, quality control, all that stuff. And then we would incorporate it into our builds, do all of our final machining or assembly or whatever we need to do. So in that old methodology, without having all of the manufacturing inside, the R&D prototyping was different. We would either send a quick build prototyping shop, that you'd upload a 3D model and they would spit you out a part that are a little,
Loose tolerances.
near net shape.
They're
but
not the best. Yeah.
Or you'd send out to that manufacturer and he would, because he's going to have to program it anyways, so he would start to bring it up on the machine and you would do like some prototype parts that were probably like a 10x of manufacturing cost. And it would take 6 weeks or it'd take 9 weeks to get a part.
Yeah, now it's like 16 weeks.
9
18
weeks times 60 receivers,
Yeah.
right? Now, the good thing is their guys generally were able to deliver, they would solve the manufacturing problems and deliver a good part that first time. So you're evaluating your design, not necessarily the manufacturing or manufacturability,
Yeah.
but never could have done it. 1,000 parts, never could have done it in, what did we have, a year and a half time frame?
Yeah.
Approximately.
Year and 3 months, I think.
Yeah, we had a little work done before we kicked off the project officially, but
Yeah.
not a lot.
Yeah.
Not a lot of it carried over, did it?
No, there's a lot of fresh stuff into this receiver.
Well, I think I wanted to just spend a little bit of time talking about vertical integration. So my goal in Gunwerks is to get control of as much as I can so that we can deliver good quality products on time.
Yeah.
That's 100% the goal. And that's what this whole new facility was about. The massive investments in, our ERP software system, machines, people, capabilities. Like, all of that is for the net result to benefit the customer in better quality, hopefully lower cost if possible, and on-time delivery.
Yeah.
Like that's the magic three, right? It's what we're always evaluating every time we approach a project. Because we play in the premium space, and we're not willing to sacrifice, features and quality. Generally, cost, suffers just a little bit. I don't like to see the delivery time suffer. It's just that's a problem. And every time we have a vendor that kind of slows us down, or there's an interruption for whatever reason, I mean, the last 2 years have been
crazy
Yeah, pretty brutal.
Yeah. So I think that's really, really important to share that story of bringing those machines in and tooling them up and setting them up and, training the people and bringing the right people in, because that's just as big a deal, I think, as, creating the design.
Yeah.
It really is.
Yep.
Yeah.
And those guys in the shop, like Jim, Jack, this thing wouldn't happen without those two.
No way. Yeah.
Exactly. Yeah.
I mean, awesome dudes.
A lot of hard work.
Yeah,
into
and
it
you
on
can
their
trust
end,
them.
too.
You can trust them to deliver.
Yeah.
Like they'll deliver what you need.
Exactly.
Yeah, no, that was pretty cool.
I mean, really, with where we're spooling up, like the only real supply chain we'll have is raw material. Right?
Exactly, that's the goal.
Yeah.
Yep.
And
Yeah, you get carbon fiber sheet, you get aluminum, billet. You
whatever
get
it is.
yeah.
Yep.
And raw materials can still be a challenge at times, right? I mean, like.
But the nice thing about a piece of 70-75 bar or rod is there's more than one supplier.
Yes.
Yeah.
Right? Like if you switch a supplier on a machined part, it could take 6 to 8 months to bring that up to speed and to get it into production and qualified. 6 to 8 months. If this supplier's out of, 2-inch diameter, 70-75, T6, aircraft aluminum, go to that supplier. He's got it, costs 20% more, but you can get it and you can be in business.
Yeah.
It's a big deal. Same thing with barrels. Like you vertically integrating barrels for us is a game changer.
Oh yeah.
Yeah.
Now all of a sudden, complete control over quality. I can't tell you how many different guys have shipped us stuff that was a little sketch. And now we have 100% control. And now we're just buying, our German-made, 416R stainless. It's just primo.
Yeah.
Yeah, I remember that was one of the big hurdles. We got early prototypes going for these assembled rifle systems and validating them, right? We have a rifle that hasn't been shot before, aluminum action, a new barrel joint, a new bedding system, and we're trying to prove it all out together, and it's a lot of variables. And to not be able to trust the barrel that you're shooting out of is a tough thing to overcome.
We agreed to send Tom Beckstrand a rifle. So Neil Emery set up basically an article with Guns and Ammo and talked about this new gun. And so got everybody excited. And they're like, okay, send us this rifle. We scheduled it to go on a hunt, on an out-ed hunt. And then he was going to do an evaluation and a write-up on it. And so my dad taught me when I was growing up, your job or your project will expand to fit the time that you have. So we had this hard deadline. Guess what? We pushed right up to the end. I remember the night before we shipped that rifle to Tom, we were putting it together and trying to figure out how to make it work.
Yeah, I mean, it's 8 o'clock on Friday. The gun gets on a plane Saturday morning at 7 o'clock.
Yeah.
And we're shooting it and going through all the checks that we do to figure out if a rifle will shoot or not.
I tell you what, that exercise though had a lot of value for our engineering team. Like, 'cause none of us have a ton of firearms experience on the engineering side, right? Like we're all big hunters and things like that, but that little exercise, like it got our troubleshooting skills right up to snuff where they need to be, I think.
Yeah. You guys are glad I was hanging around, weren't you?
Yeah.
Yeah.
Well, there's a lot of tribal knowledge there, right?
Yeah.
I mean, we are avid hunters and we all use the products, but as far as past engineering experiences, I've never designed a receiver before.
What I want to say is you've never made a crappy gun before.
There you go.
You make a gun that doesn't work, you figure out what the problem is, and
Exactly.
you make 10,000 guns, you learn pretty quickly or over time. These are the things that have to be right. Now, one of the things, just like a shift, is we were doing a new bedding system that was part of that Arca rail. So it was just a little block, and that was the whole wedge, recoil, Like it changed everything that we were doing normally.
Yeah.
And we were using that Arca rail to put a lot of the normal aluminum bedding block, strength and support with just that aluminum pillar in the back. I still think there's applicability there and some weight savings and potentially opens the door for some other manufacturing methods on the stock. Yeah. But what we found was we could not get a consistent bedding in the way that we like to mechanically secure the receiver to the bedding.
Yeah.
And that gun went on that hunt with that bedding system, and it came back the next week, and we had like 2 or 3 days.
Yeah, we pretty much had a bedding block ready to go.
Yeah, that
right
we could kind of work through it. So we literally rebuilt that entire gun when it came back before we shipped it out to him to do the evaluation, and put that new full length bedding block, same as our normal design standards, and it functioned the right way. But there was 3 or 4 things there that were just little insidious challenges that we had to overcome and identify and adjust design on.
And one of them was the receiver, right? I mean, we are building a receiver that you can swap barrels out, have a clamping mechanism, still Remington 700 bolt spacing on it, and we had different ways that we could split for the clamp, essentially. And this was our first time really testing it thoroughly. And
our FEA stuff, like when we modeled it up, our FEA was all about safety.
Yeah, yeah, we were trying to not rely on the action at all. Make it safe enough to where if the action wasn't there, it would still shoot.
And so the clamp and the loads was about trying to secure the barrel, but make sure that it doesn't strip the threads or yield the clamp anywhere.
Yeah.
But we didn't even think, because the clamp is also the recoil surface. Didn't even think about the effect of the clamping loads and how that space would work out there.
Yeah. So, and then one of the exercises Josh did, and he could speak to it maybe a little bit more, but doing FEA on different torques and how they can affect the surface parallelism, I guess you could say, of the lug face, because it's split into two.
So now we've got a very specific torque arrangement that yields a flat recoil surface that mates with the bedding block perfectly.
Yeah, that was a good day. I mean, there was a lot of theories floating around about torques, and I went and ran some finite element analysis on it, and I said, I think this is a valid theory. And Avery and I one day, we just were kind of like, well, enough with the theories, let's just go test this. And we took a full day and a half just trying different torques and changing the torque of one fastener at a time and going and shooting a group. And we really drilled down on a good torque standard for the entire system, for the clamp screws, the wedge screw, the action screws, everything.
Well, and the goal was to accommodate that, but also accommodate the user ease of it, right? We didn't want 8 different torques on this rifle, right?
Not at all.
We wanted it to be where you could do it with 2 torque wrenches or one
two
that
settings.
2 settings.
25 inch pounds, 65 inch pounds.
Yep.
And we cover everything from the wedge to the barrel clamp to the receiver screws, everything.
And
but
we were able to
tested anything from 5 inch pounds up to 95 inch pounds.
Yeah.
All the different fasteners.
We had to find another torque wrench because some of those weren't going high enough. Getting 95 inch pounds. I think we stripped out a bolt trying to get it clamped down. So
one of the things that came out of this for me was a real appreciation for what 70-75 can do.
Yeah.
It's a pretty impressive material. And compared to a 60-61 aluminum, it's substantial.
Oh yeah. Definitely.
Yeah. I think, Josh, I mean, from your past experience, you could kind of tell me better, but it's 60, 61, and 70, 75 have similar elastic properties, but when it comes to yield, that's where you go leaps and bounds above.
Yeah, and that's always driven me nuts. A lot of people see the 70, 75 aircraft grade aluminum and think it's stiffer and stronger and all that, and really it's got the same stiffness as the 60, 61, which is the inferior aluminum there, but it's just got the higher yield and higher.
Yeah, it doesn't go plastic.
Yes, exactly.
Yeah,
so it deform.
Basically take a lot more abuse. Yeah. So if we back up and talk about barrel joint a little more, so if you think about what are the really cool features that we've created in the Nexus, I'm going to say grip, and I'm going to say user changeable barrels. So if you look at the user changeable barrels in the context of I made you do it with Remington front screw spacing, Like it just locked us in on what we could do. And we developed some cool technologies there. I mean, we filed for patent protection over that arrangement. And it's unique enough. I'm confident that will yield us a really valuable patent about how to do this. So the user can, with a size 25 Torx, he can take apart that whole thing, drop the stock off, 2 screws, barrel comes out, new barrel goes on. You know, if he needs to change, bolt face, he can pop the bolt face off and accommodate any cartridge.
Exactly.
It's a really, really cool setup. And basically, you buy a gun in, say, 300 PRC. One day you want to change it. You want to do a 6.5 PRC, done, right?
Yep.
You want to do a 28 nozzler someday. It's like maybe that's an option. 375 Ruger, that's an option. So all these things can be incorporated, and the user can just change his gun at home.
Yeah, and it's not even just Magnum cartridges, right? Like 6.5 Creedmoor, you take a short action standard bolt face cartridge, and we adapt for it kind of in the magazine a little bit, but it also allows the user to swap bolt heads from standard to Magnum.
Yeah, exactly.
And achieve some cool things.
Yeah, so the popular thing right now in the Remington 700 space is bolt together guns, which is takeoff barrels, right? Or pre-fits. I mean, so they're kind of ready for the user to assemble. There's a lot of risk in that if you're not real well versed in what you're doing and how to achieve success. There's nobody with expert eyes checking before you're pulling the trigger. But if it's done right, and like I said, that's a nice way to change around. But you got barrel vices, you got big torque wrenches, you got a bunch of things in there that are a little different. And what we've developed is a very nice system. And my goal, like a little side goal, I'm a real nerd about like very subtle performance features. And I think you guys have been brought up to speed on this barrel joint problem. Like the Remington 700 space with a 60-degree V-thread, whether it's a 16, 20 pitch, whatever, 1 inch, 1 1/16, whatever the size is, they all have the same problem. That thread form puts all of the load on the first few threads of that joint. And so you've got an inch of thread. You've got, 20 threads?
Yeah.
But only
You're
the
only
front
using
three are there. And
contacting.
so what happens is you tighten it up until everything starts to yield, and not quite that much, right? So you can get about, with good lubrication, maybe 115, 120 foot-pounds of torque before you yield a shoulder or face of the action or threads, right? So that's all the tighter you can make it. And if you look at with the good lubrication, you look at what your axial preload is. In other words, the clamping force that holds that joint together. You're only around 8,000 pounds. That seems like a lot, right? You go take a Magnum cartridge, right, with a 532 case head, and you put 65,000 psi inside of that brass, and you'll get 8,000 plus.
Oh yeah.
Pounds of force applied to the face of the bolt. And if you do that, right, you're basically stretching the barrel right off of the receiver.
Yep.
And so that barrel joint can come apart, and then it'll go back together, come apart and go back together. And that's why you see like industrial locking agents. It's why the use of CNC equipment to cut those threads is so important to get a really good surface finish. So it kind of goes back to the same spot every time. But it's also, when you look down range, it's like you'll get these behaviors where your gun will two group. Like you'll shoot these really small groups, but there's two of them.
Yeah.
Right? I mean, that's one of the indicators of barrel joint problems. Sometimes it's just random and it's just a big group, but so for me, I mean, we're doing this design and I give you these guidelines, but I snuck in a few things very specifically to try to control this barrel joint problem. One of them was
Spiral lock.
ramp threads in the barrel extension. So when you torque that up, all the threads carry load. You can torque it way more than that 8,000 pounds of preload. So that barrel joint never comes apart.
Yeah. Well, and that brought another challenge, right? So we have a barrel extension that's fixed onto a barrel, and it has full thread contact. We want to leave that system alone. But we had to make it compatible enough to where if you swap barrels and not bolt heads, it still has to head space.
Yep.
So that challenge is kind of overcome by by probing all the faces in the machine on the manufacturing side.
For every part.
Every part.
Yeah.
So in the program, it will probe those faces and make sure that they're the same no matter the tool wear.
Yeah, so
or
the
anything.
goal is we keep our surfaces plus or minus a few 10,000ths of an inch of nominal, and then you take 3 or 4 of those surfaces, add them up, we get a range of values of 1.5 thousandths or less, and our range of headspace values are 3 to 4 thousandths, so we can land right in the middle of that with tons of room. That way, every barrel extension is interchangeable with every bolt head. So that way it's just total ease of interchange. So if you need to do a new barrel, you don't have to buy a new bolt head to go with it. It doesn't have to be matched. You can use the old one if it's the right caliber. If it's a Magnum size, done.
Yep.
So that'll save guys on barrel upgrades. Well, I think that in my opinion, right, I don't have like tons of data, but in my opinion, from what I've seen out of these guns, is that their potential for precision is better than the normal thread style because it clamps it tight, and we've got that extra little special thing that we're doing, right? It is absolutely centered, and the barrel joint doesn't move, and I feel that the potential is significantly greater for good precision performance.
Yeah.
So the data that I'm seeing, we're using the same barrels, we're making the same barrels on both, but the data that I'm seeing is these guns shoot. They really do, and that's what everybody that's had one and tested one is also seeing that. So we're really, really excited about that. That's been a burr in my saddle on the receiver design for a decade, and I feel like we've addressed it, and in a good way that doesn't make things
simple
harder.
way.
Yeah, it's like it's easier, it's better.
Yeah.
I would say that is a really key element of this whole system is this ability for the user to have a future-proof rifle. Like whatever comes out, whatever's next, he can get into it for just pennies, like $1,200-$1,300.
Yeah.
Well, and like you end up shooting a barrel out. It's a big pain to send your gun to an FFL gunsmith and have him take the barrel off, re-headspace the new barrel, all that stuff. Where we've kind of solved that, right? I mean,
I think about our guys in Africa. I'm just getting ready to go to Africa again, and I'm taking one of these rifles, and I'm going to show them, and they're going to hate me because we've exported a half dozen of our other systems down there, which are awesome. But they shoot them so much, they already have run into the barrel issue. And I'm going to take this down there and I'm going to show them, and I'm flying with 375 barrel and another barrel. And so I'm getting down there and they're just going to be like, oh man, we got to have one. So all of their stuff's obsolete, right? And they're going to want to have the new thing over there. Because then, a customer could literally take a barrel with him, an extra barrel with him. He could leave a barrel as a tip. Barrel's not a serialized controlled item.
Exactly.
It'd be kind of an interesting, scenario for him. So, and because they interchange, that's pretty cool. So on the grip side, other than the shape and the leather and stuff, I would say the big development was finally getting Trigger Tech to give me the adjustable trigger shoe. We've had a couple different prototypes over about 5 years, and we finally have pushed to get there. And we've got a system that looks like it's going to work really good. It's toolless, so you can get in there and you don't have to really do a lot of wrenching. And
a little lever, you slide it open, and then you got a 1/2 inch of adjustment, which a 1/2 inch of adjustment in a trigger, that's almost unheard of, right? I mean, we have a 1/4 inch back of nominal and a 1/4 inch forward of nominal, and it locks in, and they have pretty intense safety specifications that they need to follow on their side. So they actually built a whole new testing fixture for this trigger and tested it well beyond what our lifetime of our guns are typically seeing. So we set a lofty goal on our end, and then they multiplied it. And were able to come through for us.
Well, I kind of got another one of my pet peeves about rifle systems is on the trigger side. So, I mean, again, you guys are coming up to speed, and you're kind of learning all these really cool things that go on in a rifle when you pull the trigger. And one of the most significant things as an engineer to understand around rifles is the harmonics of the barrel. Right? And you guys are engineers. You know that there's a lot of different modes, a lot of different frequencies of barrel motion. Most of them happen after, like they're so slow, the bullet's already gone. But there's a couple that are fast enough that they happen when it's happening, which means your barrel, to exaggerate, looks like a piece of spaghetti while that bullet's going down the barrel. And so this whole barrel timing and load development and all these things that everybody do to try to address that issue, they're real. But it's not voodoo. It's a very specific science, and it's easy to model. I shouldn't say easy to model mathematically, but it can be modeled mathematically, and you can predict what's going on. Now, you can also take steps in a rifle system to minimize it. One of the things that we've done is the aluminum bedding block and the recoil wedge that clamps the recoil lug into that bedding block.
Wedge is huge.
Because just the two screws tightened to 65 inch-pounds doesn't keep the action steady. Like it'll bounce all around in that gun because of all the loads and the forces and the vibrations and the harmonics. And so that's what we're really doing with bedding, is trying to secure that better. But with our mechanical system, we get away from the glue-in stuff, right? And we're doing it mechanically. And now you've got this really, really rigid structure. One of the biggest harmonics comes from the bending moment of the action. So with this rigid structure, it almost eliminates that bending moment. So it really reduces the barrel harmonics. And it's why our guns are able to shoot our standard factory load over and over and over again. We don't have to tune loads for a gun. We literally make guns that shoot the load. That's one of our big deals at Gunwerks. So if you start looking at this arrangement that we've put together with this barrel joint and the bedding system and everything, like we've addressed that big harmonic of the bending moment. Right? I think satisfactorily, because it really, really works. And it works with all these different manufacturers' ammo and our ammo, and it's just working and consistent. The other one, it's a smaller magnitude, but it is also important, is the vibration that comes through the bolt when you fire. And a real big pet peeve of mine in all this design, Remington 700 clone experience, is the Sear arrangement on that bolt. So everybody knows, everybody that's built a receiver, you try to tighten up the bolt to bore on your receiver tolerances so it's tight. But if you go too tight, then you can't cycle the bolt. So you have to have some space. Generally, let's just say 3 thousandths aside is tight, but not so tight that you can't still work it. It's pretty tight. I think most guys are probably running double that.
Especially carbon build.
So let's just say it's 3 thousandths. Well, when you put your bolt in there, right? And everybody knows lapping the lugs is something that's important. Well, we're going to talk about why. So you get your bolt in there, and you've got a cartridge in there, and spring plungers are pushing on. It's pushing the bolt back, right? In theory, the two lugs at the top and the bottom are going to be touching the receiver and the bolt, and you're going to get 100% contact. If you machined everything perfectly, they would be perfectly contact. So let's say we're the most awesome machinists in the world. We machined it perfectly. They're perfectly in contact. And you've got, in the back of the bolt, you've got 3 thousandths of an inch clearance around the back of the bolt. Well, guess what you do with a Remington trigger?
That ramped Sear, it pushes that rear of the bolt straight up to the ceiling.
3 thousandths. It pushes up 3 thousandths. And guess what happens to the top lug on the bolt?
You got a single point contact.
The top lug pulls away. Right? So did you lap your lugs or machine your lugs with the bolt all the way up, or did you do it perpendicular? Right? Or when you lapped the lugs, did you do it with the trigger in? There's all these weird little things there that are so important. But that, when you pull the trigger, right? And the cartridge goes off, and you get that 8,000 pounds of force on the bolt face. Guess what happens to that top lug? It touches. And the back of the bolt comes down, and it goes ding, and it's just like ringing a bell. And that will transmit up through the barrel before the bullet exits. Right? So one of the things that we did with this trigger is we moved to a vertical sear. You remember me telling you, this is what we have to do. Right? And there was discussion Remington trigger, and I said, nope, not going to happen. It has to be vertical. And with a full diameter bolt, there's some other things going on there. But anyways, it's the right solution for a couple different problems. But that is one of them that we fixed, You may not have known that we fixed that, but we fixed that when we moved to this type of a trigger arrangement. And so there's a half dozen little adjustments in very, very small things that we've built into the system that address some pet peeves and some engineering obstacles that I've had in that Remington 700 platform. And I'm so excited about the performance that we're getting and what that means for the customer.
Yeah. And just kind of take a step back and kind of touch on one of those points that you said, the bedding, the system, and the harmonics going through that, and how our recoil wedge eliminates a lot of movement in there. But there is still movement. It's
You can see it.
Yeah,
you take it apart, you see it.
You can't make it go away. And one of the really cool things about the Type 3 anodized aluminum, right? It's a very slippery coating. And so if there is any shift in that bedding surface, it will slide back. It's not sticky
back to
like
home.
You go back to the
paint
aluminum
coatings.
and its nature to move, right?
Yep.
And now it comes back. Yep.
Yeah.
Exactly.
Yeah.
And so like a big problem with Remington 700 clones, a lot of them steel, stainless, whatever, Cerakoted. And that Cerakoted, it's a softer coating. It's not quite as hard as a anodized would be, and it's not as slippery as an anodized would be. So a lot of those kind of get set into their spot, and they'll move and they can stick, So we are
back to that barrel joint problem that we're talking about.
exactly. Yep.
Yeah, no, that's absolutely true, and I'm kind of excited about this finish. So Avery's talking about a user experience here in the finish. We're only doing one finish, and that's Type 3 hard coat anodize.
Yep.
We're looking for a really, really durable surface, increases the surface hardness of the aluminum, and it's really, really wearable. Like, these are the type of finishes that go on military duty type products, like just abuse and hard use and still functioning. But I think one of the coolest things about the Type 3 is the bolt bore, right, in the receiver, and the way that we set that up to hold lubricants, right, and then combine that with a really slippery finish on the bolt, and it just gives you an experience cycling that bolt that you just don't get, with that other style of receiver. So very excited about that. I really am.
Yeah.
It's pretty cool. There's two other features that I want to talk about that the user is going to see on this. I just want to mention them in passing. Well, actually, one's going to be in passing. One's going to be a big bitch session about how hard it was to create. But the first one is integral Picatinny rail. And we did 2-piece, and we did fix it so it behaves just like a 1-piece. So everything's spaced out correctly. Caught that about 2 weeks before we finished and did one more iteration. But that, if you think about that barrel joint and the front, and then how that clamp is right there, like, we've got a really, really good connection between our scope and the barrel. Like, it's a very good structure, and that's another place where you get some movement. But I'm very satisfied with that. So integral Picatinny base. So one set of rings. You've got one less joint that you have to worry about moving. It's a good system. It really is. The last one is the 3-position safety. Right?
That one's the pain.
That one's the pain. So what we wanted to do was kind of do a throwback to like a really popular classic, product, which is the Winchester Model 70 Classic, right? I mean, that old pre-64 or the classic version that was later had a 3-position safety on the shroud. And what it does is it literally blocks the entire fire control system, firing pin, cocking piece, everything. It blocks it mechanically from dropping on the action. So it is the most robust safety type system that you can put together. So we built this system, and what I really wanted out of it was a bolt that would lock closed. Right? So all the way back, bolts locked closed, everything's safe. So I that was a big challenge. Avery invented a new way to produce that safety system that wasn't the classic way. And it gives us some advantage in manufacturing and the materials that we can use. But it was a challenge.
Yeah. I mean, there's a lot of things to overcome there, right? Like, so typically 3-position safety, it has to move that whole firing pin back off the sear quite a bit. And you're talking about 22 to 26 pound firing pin spring. That's a lot of force with just a little lever. So we kind of had to fine tune it a little bit, right? That's where our iterations came in, vertical integration, right? We were able to make those changes quickly and adapt to make it how we wanted it, to get a good feel out of it, to be safe, right? As a safety should be.
Yeah.
So,
and it's pretty good. The thing that I was struck with was how perfectly suited a 3D printed part was for that lever. And you did a great job of making that lever give you bite and control, but also feel comfortable. Like it feels good. Like the first couple versions, not so much.
Yeah.
The last version, you actually nailed it on that one.
Dialed it in a little bit. Yeah. Yeah. We started with some just CNC mill operations, right? Some 5-axis parts to make these levers. And we couldn't get what we wanted out of it. Not if we didn't want to stitch the entire thing. Yeah. We'd have a 3-hour machine time on a safety lever. Right. So we had to look at the alternative methods, right? Some additive manufacturing seemed to fit
I've
the
been
role.
dying for a chance to use that. So we actually use 3D printing for 4 parts on this. Safety lever, magazine catch, extractor, and bolt stop.
Yep. The wedge too.
The wedge is as well. Okay, 5 parts. Very nice.
Switched that.
Okay.
So, and
there's some challenges using them, but the cool thing is this is 17.4 pH, right? Are we doing a hardening afterwards?
It is a H900 heat treat.
Okay.
And then they're black nitrided.
Yeah. So this is got a really hard surface finish.
It's like
and
42 HRC, and the black nitride will wreck a drill bit if you try to use it on there.
They're permanent parts. I think for the things that we used them for, the finish and fit is right. Yeah. There's some challenges with precision parts, but I think these parts are exactly right for that type of manufacturing.
Yeah.
And have you had some experience in 3D printing?
No,
and neither of you?
No.
So this was kind of new for all of us.
Not metal
very
3D
cool.
printing. Yeah.
Nice.
Yep. So metal 3D printing. This was first thing we've ever done with them. I mean,
that technology has come to the market in the last 5
I've been trying
years,
to
maybe?
justify buying one. We're a long ways off.
Yeah.
Oh yeah.
But it's really tempting.
Yeah.
Because it's really cool tech.
Yeah,
I think we'll get a Swiss machine before we get one of those. One of the questions that's come up is leather grips and maintenance and service. So maybe just talk to us just a little bit about kind of your expectation for how the leather itself is going to hold up and weather, and what's going to happen when we need to replace one.
Yeah, I mean, as I spoke earlier, one of the things that went into leather selection is durability, and a lot of the durability comes from the weatherproofness of the leather itself, and that comes into the oil content on the leather and things of that nature. So, as far as weather goes, it'll be water resistant. We're not going to have any concerns there. And then durability, it is leather. It's going to scratch. There's not a scratch-proof leather out there in the world, or we would have found it, I think.
Why would you want it? That's the whole point of leather is the patina that it gets over time.
Exactly. Yeah. So, I mean, that's just a disclaimer to throw out there, right? But and then as far as the grip itself goes, it's sewn to a mechanical backer, and it'll be attached to the stock with basically a double-sided adhesive. And so if your grip gets ripped, torn, anything like that, be able to call in, order a new grip, and then peel it off. It'll have an adhesive backer right on the grip itself, and stick the new one on.
Yeah. Okay, that's the goal. So we've got a little testing to make sure that that's right.
Definitely.
But worst case scenario is we can service it here at the factory.
Yeah, worst case scenario.
Worst case scenario.
Yep.
So the 2 types of leather: vegetable tan, chrome tan. Right.
Yep.
So the leather that we're used to on like a really nice saddle, or a really robust belt.
Yeah.
Or some gloves or things like that. That's vegetable tan leather.
Yeah.
And it actually is a really nice product that'll just kind of wear and fit and shape, to the application.
Yep.
What we're using is chrome tan leather, which doesn't have the same oils in it.
Correct.
Right?
Yep.
And it's done with chemicals in a way that it is much more impervious
Yes.
to conditions.
Yes.
So the idea is it's a fairly all-weather product. And there's a handful of really high-end guns that use some leather in it.
Yep.
And they have a long track record of using that. And
Yes.
think about your phone case, like a leather phone case, and the abuse that goes through.
Yeah.
So I think we have really good history of that type of product being very viable in this space.
Yeah.
And the touch of the leather
awesome.
versus like a crappy synthetic rubber, it's superior.
Even the chrome tan versus the vegetable tan leather, I think it's got a much better tactile feel to it as well. It's a lot softer in nature. It's got a little sponge to it almost.
So the talk around here is basically that because we're doing a carbon fiber stock, we're not painting it, right? It's carbon fiber.
Yep.
We're doing anodized aluminum on all the aluminum finishes. So there's no paint options. Like the gun is the gun. There's some talk that potentially the high-end customization on this rifle is whatever leather you want. So I just want to shout out to Mercury Leatherworks here in Cody.
Yeah.
Real high-end saddle maker.
Yeah.
Anything leather.
Anything leather. Yeah.
I'm talking really high end. He stepped up to the plate here and helped us out to do our first like
Pilot
25 pilot run.
Yep.
And he did a great job, really, really crushed it. And he's set up now to do some customization stuff in the future. So we'll see if that program comes together or not.
Yeah.
But it could be pretty fun.
Yeah. I could not believe the different types of leathers that he had in that shop, and like places I've never even heard of in the world that they were coming from. And they were like hides that there was only 20 of them that existed in the world, and he was able to get a hold of them. And it's a pretty crazy industry when you start getting into the details there.
So let's recap. I think we've hit the end of our time. Let's recap what we're launching with. So the NXT Action, assembled in the Nexus stock, creates the Nexus rifle system. This is our nomenclature. Yep. So Nexus rifle system will be launched at the end of May. So this may or may not air before or after that, end of May, with 6.5 PRC and 300 PRC barrel options in 20 or 24-inch barrel lengths. So basically, there's your options.
Yep.
We will have, I think you've completed the 375 Ruger barrel in carbon.
Yep.
I haven't shot it yet. I suspect it's going to be a lot.
Yeah. It won't be the most pleasurable, but
all right. So we will have that barrel ready as an accessory. That'll be our first accessory barrel, and we'll continue to develop those as accessories that guys can buy to add to the system. So that is the package that we're launching with. The main features in the Nexus rifle system are this next grip style, right? Yep. It's the 3-position safety, the integrated Arca rail. I would say that's the main
switch barrel.
Yeah, switch barrel. Yeah. You've got the touch points of the leather. You can go check one of these out at the website, gunwerks.com, go to the products, rifle systems, and then Nexus. And I just want to end on a point. This name was perfect. I love it when somebody else picks a name. I don't pick it because it's like perfect. I didn't have to use brain power to come up with it. This is probably one of the first rifle systems, a mainline Gunwerks rifle system that somebody else has picked the name on. But it's a great name because what it does, not only the NXT represents the next, forward-thinking version of where Gunwerks is going, but the Nexus indicates a crossover point. Like this is the focus of everything that we've ever done, and it's the launching point for everything that we're going to do. So the name is perfect for this rifle system, and I think that our customers are going to be very excited about it. And if you look at the price point, we are super competitive because of everything that we've done. We're able to sell this for less money, even though this is the flagship. This is the premier Gunwerks rifle system. The cost is less. And so there's going to be a disconnect because usually you think more cost is better, but we're actually delivering on the quality, features, and we're delivering on the price. So as long as we can keep up with the manufacturing, then we'll work on that leg as well. So vertically integrating it is going to help us do that.
Exactly. Yeah.
So thanks to you guys, really big thanks, and the rest of the engineering team. And super big thanks to the guys out on the floor who helped us iterate and optimize every single dimension and part and piece on this system to make it what it really is. And all the rest of the team that's involved in this. It was a big effort. It's a huge thing for a small company like us to do a ground up development from scratch and solve all those problems and learn and understand how everything works. But the truth is, I got 2 expert engineers now that can do anything that I want. It was worth the investment on my time.
I wouldn't go that far.
Okay, anything that I ask of you. We'll just back it off a little. A couple things. It's a lighter gun. We didn't design this to be the mountain rifle, but it is a lighter gun. It is just over 7 pounds with full Arcas, all this stuff. That's with the heavy steel bolt. So, potentially there's a titanium version of that bolt that would actually bring the gun weight to probably just under 7 pounds. I'm thinking. So pretty excited about where we landed on weight. That receiver just about hit the titanium receiver weight.
2 ounces.
Out of aluminum. So it's very cool. Very cool. So magazines also. Right now we're doing aluminum. Potentially there's a carbon or injection molded composite option available. But for now, you're getting a really high-end aluminum machined magazine as well. So
double stack, double feed, load from the top. Or take it out and load it just alone. Pretty cool. Excellent
system. So congrats. And for all our listeners, please go check this out. Take a look at what we've done. And this is the thing that I am the most proud of to date is our ability to engineer and accomplish something like this. So thanks a bunch, guys. Cool. And join us next time. Don't know what the topic is, but it'll be good on Long Range Pursuit. If you like what you're hearing here, please take a second and give us a 5-star rating and a positive review on iTunes or on your favorite podcast app. We appreciate your feedback and suggestions for topics you'd like discussed or questions you want answered on the podcast. You can reach out on Facebook or Instagram or send us an email to podcast@gunwerks.com. Also, be sure and check out our full offering of long-range gear at gunwerks.com. Use promo code LRP for free shipping on any order.